Hey everyone, welcome to section 4.1 where we're going to talk about linear functions and their models. And then for 4.2, you're going to go to Canvas and you're going to watch the video that's in the module for week 5. It has to do with your project. So remember we talked about slope-intercept form of the equation of a line, which is y equals mx plus b. If we want to express that as a linear function, then we're just going to replace the y with the f of x. So the equation would change to f of x equals mx plus b. And you know that for linear functions, the domain is the set of all real numbers. And the first way it's expressed is set builder notation, and then the second way is interval notation. And it's important to know both ways. Okay, so if you're given a linear function like f of x equals negative 3x plus 2, how would you graph it and what would be the domain and range? So one way to graph it, since it's already in slope-intercept form, is to pick out your m and your b. So if I look at that equation, my b is equal to positive 2, and my m, which is my slope, is equal to negative 3. So remember that one way you can graph that is to begin at the y-intercept, so begin at 2. So I'm going to put a dot on 2. And then slope is rise over run. So my rise would be 3, and I'm going to go up 3. And then since it's negative, I'm going to run left 1, since my run is 1. You can also go down 3 and right 1. Whatever works for you, but you notice that you're still on the line there. And then just connect it. And of course, to show that it's a line, we're going to add arrows to both ends to show that it goes on infinitely. Okay, and my domain, since it's a linear function, is all real numbers. And the range is also all real numbers. Every x is going to give you a different y value. Another way you can graph a function like that is to make a table of values. So here I've already created one for you, and I chose negative 2, negative 1, 0, and 1 for your x values. So after plugging those in, it gives you the corresponding y values. What do you notice about the variables and the numbers that are given for x and the output that you're given for y? So what you should notice is that x is increasing, and every time it's doing that, y is decreasing. So we would refer to this as your change in x and your change in y. As x increases by 1, y decreases by 3. So here we would say our change in x is positive 1, and our change in y is negative 3. This is known as the average rate of change. What does it seem familiar to? So it should sound like slope, and that's all it is. So the average rate of change is just the slope. Okay, to find the slope, we know that we would use m, and it's change in y over change in x. So here I would have negative 3 over 1, which simplifies to negative 3. On a linear function, slope is always constant. So that's really important. It means it's not going to change, right? If you think back to constant functions, which are one of your 8 common functions, it was just a horizontal line. So it had no increase or decrease. If you want to pause the video, you can read the example, and then we can talk about it. So it says a strain of E. coli is placed into a petri dish at 30 degrees Celsius and allowed to grow. The data shown in the table are collected. The population is measured in grams and the time in hours. Plot the ordered pairs in the Cartesian plane and use the average rate of change to determine whether the function is linear. So remember, if it's linear, it means that the slope will be constant, or the average rate of change will be constant. So I already have the table drawn for you, and I'm going to look at my x's. Notice that time is increasing by 1 hour, and as time increases by 1 hour, we have population increasing by 0.03, and then 0.04, 0.06, 0.07, and then 0.1. So my change in x is constant, but my change in y is not. So if you look at the graph, you can kind of tell it's not a linear function, that's a curve. So here, the average rate of change is not constant, so therefore the function's not linear. Okay, that symbol means therefore the function is not linear. And we'll talk about functions that are not linear. Here's some more examples. So if I look at this table on the left, we need to determine whether each function is linear or nonlinear. And if it is linear, write the equation that models the data and state whether the function is increasing, decreasing, or constant. Okay, so if I compare my x's, they're increasing by 1. And my y's look like they're decreasing by 3. So I know that my change in y over my change in x is constant. It's -3 over 1, which is just -3. Okay, this negative tells me that the function is decreasing. So as y is increasing, x is decreasing. Whereas x is increasing, y is decreasing. Okay, so since this is a linear function, since it does have a constant average rate of change, I need to create the equation for that function. So if we were to write a function, we would want it to be in the form of mx plus b. Okay, I already have m, which is -3. I need either b or I need to find a point and work backwards to figure out what b is. So if you look at the table, are you able to find b? B is right here. It's the y-intercept, 0, -2. So I have everything I need. So I'm just going to replace everything now. I would have f of x equals mx plus b. So the function is f of x equals -3x minus 2. If I look at b, again, my x's are increasing by 1. But if you look at y, it increases by 1/4, and then by a half, and by 1, and by 2. So the average rate of change is not constant. Therefore, the function's not linear. And again, later in the chapter, we will deal with functions that are not linear. Okay, if you want to pause the video and take a second and read the example, and then unpause when you're ready, and we'll work it out. The monthly cost C in dollars for calls from the United States to Germany on a certain wireless plan is modeled by the function C of x equals 0.26x plus 5, where x is the number of minutes used. So anytime you have some kind of wireless plan, right, the amount of money that you're paying is modeled by some function. Here, 0.26 would be probably 26 cents per minute, and the 5 would be like a flat $5 fee for having that service. Okay, so it says, what is the cost if you talk on the phone for 50 minutes? So if you'll recall, the cost is the C, and 50 minutes is your X. So I'm going to take my function, C of x equals 0.26x plus 5. And I'm just going to replace the x with the 50. And if you multiply 0.26 times 50 and you add 5, you should get 18. So that means it's $18 to talk on the phone for 50 minutes if you are calling from the United States to Germany. Now in letter B, they're giving you the monthly bill, so you're paying $21.64. We want to work backwards and figure out how many minutes did you use the phone. So now we have the cost. And we're looking for how many minutes. So we need to find x. So again, here's my equation. And I'm going to replace 21.64 with C of x. And we're just going to solve for x. So to get x by itself, I'm going to subtract 5 from both sides. And when I subtract 21.64 minus 5, I get 16.64. And then I want to divide both sides by 0.26. And when I do that, I get 64. So that means if your bill was $21.64, you talked for 64 minutes. Does that make sense? To me it does, because if you talked for 50 minutes and it cost you $18, it should cost more to talk 64 minutes. Okay, letter C. Suppose that you budget $50 per month for calls to Germany. What is the maximum number of minutes that you can talk? So now we're talking about an inequality. You don't want to go over $50 a month. That's the most that you would like to spend on your bill. So this equation now becomes an inequality. So the cost is greater than or equal to 0.26x plus 5. So you don't want your costs to exceed $50. 50 is the most that you want to pay. So we would use greater than or equal to. And now I want to solve this. So subtract 5. And then divide by 0.26. And you would get 173 is greater than or equal to x. Okay, so what exactly does that mean? If I was to reverse that, it would be x is less than 173. Remember, x is number of minutes. So it means that you would want to talk, the maximum number of minutes that you would want to talk would be 173 minutes. But you wouldn't want to go over that. Okay. And then last but not least, it says, what is the domain of C if there are 30 days in the month? So remember, domain refers to x. So we know that x is minutes, and I need to figure out how many minutes there would be in 1 month. So we know there's 60 minutes in 1 day, and there's 60 minutes in 1 hour, and there's 24 hours in 1 day. So we would do 60 times 24, which gives us 1440 minutes per day. And in this month that they're talking about, there's 30 days. So I'm going to take 30 days and multiply that by 1440 minutes per day. And the days will cancel out, and you'll be left with 30 times 1440 minutes. So that would give us 43,200 minutes. So the domain could be you don't talk at all, so 0 minutes, all the way up to 43,200. Or you could express it in set builder notation where x would have to be between 0 and 43,200. The next thing we're going to look at is supply and demand, which is an application of the problems here. So the quantity supplied of a good is the amount of a product that a company is willing to make available for sale at a given price. The quantity demanded of a good is the amount of product that consumers are willing to purchase at a given price. We're going to call the price P. So suppose that the quantity supplied and the quantity demanded of smartphones each month are given by the following functions. Okay, so we have our supply and our demand, where P is the price in dollars of the smartphone. In letter A, it says the equilibrium price of a product is defined as the price at which the quantity supplied equals the quantity demanded. Find the equilibrium price of smartphones. What is the equilibrium quantity, or the amount demanded or supplied at the equilibrium price? So it tells us the equilibrium price is the price where the quantity supplied equals the quantity demanded. So here it would just be S of P equals D of P. And I'm just going to replace S of P with 15P minus 900 and D of P with negative 3.75P plus 2850. And then I'm going to solve for P. And then divide both sides by 18.75, and you get 200. So now, what's the quantity, or the amount demanded at the equilibrium price? So now I would take my D of P equation, and it doesn't matter which because you're going to get the same answer. And I'm going to plug in the price, 200. And when you do that, you get $2,100, or 2,100 smartphones. So exactly what does that mean? Like, what did you find? A lot of times in word problems, you get an answer, but you don't understand what it is. So how would you interpret that? At $200 per smartphone, the company would sell and produce 2,100 phones with no shortages or excess inventory. Okay, in letter B, it says determine the prices for which the quantity supplied is greater than the quantity demanded. Okay, is greater than refers to an inequality. So now this is just going to change to S of P is greater than D of P. So we already know the answer. If we took the expression 15P minus 900 and had it greater than negative 3.7p plus 2850, p is just greater than 200. It's the same answer as letter A, except it switches to greater than. Okay, so what exactly does this mean? If the company was to charge more than $200 per phone now, the quantity supplied will exceed the quantity demanded. So what does that mean? It means that there would be leftover, right? So therefore, the company would be stuck with leftovers. Okay, in the next one, we need to graph. I'm not going to sketch the graph, but I will show you on Desmos how to graph it. So we want our one equation, the supply equation, we're going to make it 15x minus 900. And my demand equation is going to be negative 3.75x plus 2850. And if you're looking at the graph right now, you don't see anything because the window is off, right? I need to change the window. So if I go and click on the little wrench there, we're only dealing with the first quadrant. We don't care about the second, third, and fourth because there's no negatives. When we were solving this problem, we had gotten 200 for the price of the phone. So X is 200, but I like to go a little bit more. I'm going to make X 300. And my Y, if you'll remember, would go from 0 to the cost of the, or the number of smartphones, which was 2,100. So I like to go a little bit above that. So we'll go to 2,200. Okay, and now you can see that what that looks like, and you can also see the equilibrium point. So that's just right here where the two lines intersect, and we found that point. It's 200, comma 2,100. Okay, you can practice graphing if you'd like. And then in the last part of the notes, so I'll put C Desmos. And the answer was 200, 2,100. Okay, for this one, you're using the figure to answer the question. So letter A says solve g of x equals 20. So remember, g of x is just y. So where does y equal 20? Right here. Okay, what's the corresponding x value? 5. For letter B, says solve g of x is less than or equal to 60. Okay, so now we need to find where y is 60, which would be right here. And it's asking, okay, what x values would produce a y value that's less than or equal to 60? So since it can be equal to, negative 15 would produce a y value of 60, but then the other y values would be anything beyond negative 15, so greater than negative 15, because that line's going to continue to go down and down and down, which would produce a y value that's less than 60. So anything from negative 15 to positive infinity. For g of x greater than 20, okay, I need to find 20 for my y. Now this is saying what x values would produce a y value greater than 20. So again, 5 is the corresponding x value, but all the numbers less than 5 would produce a y value greater than 20, because if I go to the left, you keep getting higher than 20 for your y value. So here, the interval would be from negative infinity to 5, and I'm putting parentheses around the 5 because I'm not including the 5. And then in the last one, it's saying solve 0 is less than g of x is less than 60. So here, g of x has to be between 0 and between 60. So what are the two corresponding x values? Negative 15 and positive 15. And again, I'm using parentheses because I'm not including those values since it says less than. I'll leave the last one for you all to try. And then there's also a little activity for you to do where you can play a game with linear equations and you can try to earn stars. There's up to 6 levels. Okay, so challenge yourself and see how you do. And then make sure, you watch the video for 4.2 because that has to do with your project that will be due very soon. If you have any questions, please reach out to me and let me know. I hope you all have a great rest of your day.